I'm sorry, I bet you didn't hear the music there, did you? I was trying to get the music turned on.
I'm afraid we didn't, but the graphics were very impressive.
Okay, anyway, never mind. Just try and share this other thing. There's no sound except me on this next one. Right, this is a talk about Far Far Out, which is an object which was discovered in January of 2018, but it was announced in February of this year, and it was confirmed to be the most distant object ever to be observed in the solar system. Far Far Out is 132 times the distance of the Earth to the Sun, or as we say, the 132 astronomical units. It's estimated to be 400 kilometers or 250 miles across its diameter. And it was first discovered in January 2018 by Scott Shepard, David Tholen and Chad Trujillo using telescopes in Hawaii. I think they used the Subaru 8.2 meter telescope in Hawaii. This is a blink image of Far Far Out, and the object is indicated by the orange lines on the image. It's officially called 2018 AG37, and Far Far Out is its nickname. The team had found another object called 2018 VG18, which they nicknamed Far Out. But just as they were about to announce the finding of Far Out, they took another look at the data that they had, and they actually found Far Far Out, which was obviously a little bit further out than the other object that they were announcing. So they announced Far Out, but then in February of this year they announced Far Far Out. This is a similar image. Obviously, the object is moving against the background and indicated by the blue lines. It moves, and the star field stays in the same place. It moves so slowly across the sky that they realized it was a very distant object, and it has an orbital period of 798 years. Because it moves so slowly, it took 3 years since its discovery to confirm the data with observations from the telescopes at Hawaii and Chile. This slide shows some of the other objects found previously. Some of them have been found by the members of the same team. I noticed the names cropping up for some of these objects that have been found over the years. And as you can see, this Far Out is 120 astronomical units from the Sun, with other objects that have been found like Sedna and Eris. Actually, the orbital period of VG18, the Far Out, is actually a little longer than Far Far Out. It's 929 years for the orbital period. When they looked at AG37, the Far Far Out has got a very eccentric orbit, and it goes obviously far out. Currently it's 132 astronomical units away from the Sun, but it also during its orbit of about 800 years, it goes within the orbit of Neptune and would go fairly close to Neptune. Any objects outside the orbit of Neptune are called trans-Neptunian objects, and the first trans-Neptunian object was found was Pluto, and Pluto is 39 astronomical units from the Sun, and it's at its furthest point, far out, is 175 astronomical units from the Sun, which is over 4 times further out than Pluto is. And it's possible in the distant past this object was thrown out into this eccentric orbit as it passed Neptune. The gravity of Neptune would have thrown it out into this orbit, and in the future it will probably pass nearby Neptune again, and may be thrown out of the solar system altogether, or alternatively Neptune may capture it and it would become a moon, another moon of Neptune, like Triton is a moon of Neptune. Again, this slide shows far out on this one, 132 astronomical units out on this diagram, with other objects that have been found. You can see Pluto is at about 39 astronomical units. This diagram here shows again a comparison of the objects and how far they are out from the Sun. Far out is at the bottom. The planets are at the top, shown in blue. The minor planets, the dwarf planets, are shown in a lighter yellowy colour, and the orangey colours are other trans-Neptunian objects. But you can see that Ceres, which is in the asteroid belt, which is classed as a minor planet, is between Mars and Jupiter. The orbital period of Ceres is only 4.5 years, so you can see that with only 4.5 years of the orbital period for Ceres, it compares with far out's orbital period of 96 years. There's quite a big difference, really. Here is a history of some of the trans-Neptunian objects and minor planets that have been found. You can see at the top, Ceres was discovered as early as 1801, and it's now, as I said, considered a planet, a minor planet. Pluto was discovered in 1930. And it was considered a planet for 76 years until it was reclassified. And then the rest of them, after 2003, 2005, 2002, there's the rest of the objects were discovered after the year 2000. This slide shows a comparison of the sizes of some of the trans-Neptunian objects. They're all smaller than our own moon. You can see on the bottom left the moon, and at the bottom is the top section of the Earth. But they're all smaller objects like Pluto. Pluto is the largest of them, but Eris is a similar size, and others are quite small, but some of them also have their own moons as well. The Kuiper belt shown here on this slide is everything in blue, that massive blue objects. There's been over 2,000 objects found in the Kuiper belt, which is just outside the orbit of Neptune, and over 2,000 catalogued objects that have been found. And some of these obviously contain are the actual minor planets and trans-Neptunian objects I've been talking about. Some of these objects, a lot of these objects have got very eccentric orbits. They're not all going around in a very nice, neat pattern around our own solar system, and some of them go well out, and some of them are in a little tighter orbits around our own solar system. This slide shows try to give you an idea of the size of far out. The Triton is the moon of Neptune, and far out is quite a bit smaller than Triton, and obviously relative to our own moon as well. Triton, far out may be, because it is so far out, it may be we can't see it. We can't get a detailed look at it, but it may be an unusual shape like Vesta. It might not be spherical. But Ceres is obviously a more spherical object as far as a minor planet goes. Now this diagram here shows the Kuiper belt indicated in blue. The center of the solar system would be to the left, and outside the Kuiper belt there is an area called the scattered disk. And Eris is also quite a large object, and that's in the scattered disk, whereas some of these objects like Pluto, Haumea, and Makemake, they are in the Kuiper belt itself. There are objects farther out than far out. There is the Oort cloud, the Oort cloud, which is obviously outside the Kuiper belt, and this consists of they think it consists of lots of rocks and ice, which are in a mass around in a big cloud around the solar system. This diagram sort of like tries to give you an idea of the extent of the Oort cloud. And the outer part of the Oort cloud is possibly 50,000 or astronomical units or more outside, away from the sun, and that's getting on for nearly 3/4 of a light year from the sun. Alpha Centauri is 4.3 about approximately 4.3 light years away from our sun, so that's our nearest star. But and obviously this is this is a logarithmic line along here of the distances. But you can see that the Oort cloud goes out quite a long way. And Voyager 2, which is currently on its way out of the solar system, has passed, has just round about 100 astronomical units passing through the terminal shock wave from the sun and the heliopause, and on its way out towards the Oort cloud. This is not a small moon, as they said in the film. And just to end, this picture put together by the Sun newspaper, which is where I did all my research. It shows you the approximate size relative to Great Britain and Ireland. So that's me. Thank you. That's finished. Thank you.